Okay, so here we see some problems with polynomials now, not just goofy numbers. I'm going to do an equivalent example beside it as well. You actually did this last year. This is called the distributive property, where this 3 out front here, okay, this has to get multiplied by everything inside the brackets. In other words, it's going to be 3 times x gives you 3x, and then 3 times 7 is 21. Because the 7 is positive, and so is the 3, the answer is positive as well, so positive 21. And you can also boil that down to an area problem like we did before. Look on the right there, and we can write that as being a rectangular problem as well. In other words, I could write this as 3 times 10 plus 7. And the same rules apply, right? 3 times 10 is 30, 3 times 7 is 21, and you add the two together to get your answer. So we can do this with algebra, all these different polynomials too. And last year you were introduced to the concept of algebra tiles. We're going to be looking at those. I know how much you loved them last year. Looking at those again as well. So let's look at a problem involving two polynomials, like two binomials with algebra tiles, and we'll do it that way. So here's a problem involving the multiplication of two binomials, okay? And the distributive property still exists and still works, but it's just a little bit of a different format because now you're multiplying by two things out front, not just the one, not just the 4, but the x as well. And how does that work? If you look at it from an area problem using algebra tiles, it might become a little bit clearer for you, and I'll just draw out what it should look like for you. Okay, so if you remember the algebra tiles from last year, the long skinny ones, the green ones there, are the x tiles, and the single ones, each of the small squares are the constant terms, and then x squared is like a big green box, okay? So here I have x plus 4 on the left here, and x plus 3 on the top there. And if you can imagine these lined up the way they are, the area in between would be the result of the multiplication. So let's look at what shapes are going to take place here. Okay, so this might look a little goofy at first, but if you think about the space that was here, okay, this space is occupied by something that is x by x units long and wide. In other words, by x squared. Hence, my x squared tile there is in that space. And likewise, the space that is right here is occupied by something that is 1 unit wide by x units long. Hence, a 1 by x rectangle, or 1 times x is just simply x. So that's an x tile that goes there. And so you can sort of see how each of those tiles, those algebra tiles, fills the space that it should. And if you add them all up, then this is what you get, x squared plus 7x plus 12, because there's one x squared tile, 7x tiles, and 12 of those red single tiles, okay? And so we can do that with any kind of polynomial where there's two binomials. You kind of find the area of the resulting rectangle. Let's try another one here, and maybe you can work it out a little bit on your own as well. Okay, so looking at this one here, we have 2x minus 1 and x plus 7. So first thing we're going to do is you're going to illustrate this multiplication using algebra tiles. Keep in mind that negative tiles are white, okay, and so green and red for solid colors when they're positive, and just plain white when they're negative. So it's going to look like this when you set it up. Okay, you'll notice that that one tile down here on the bottom left here is left uncolored because it's the -1, this guy right here. Okay, and again, negative tiles are left blank, they're white. Okay, so then to find the answer here, we're just going to fill in all the areas, remembering that a negative times a negative is, negative times a positive is a negative number. So go ahead and draw in all the resulting areas that are a result of this multiplication and see if you can come up with the answer on your own. Okay, so you'll notice that that whole bottom line is all left uncolored because it's a negative number. This is a -1 down here, multiplied by these positive numbers up top. And so anytime you multiply a negative by a positive, you get a negative answer. So they're all left like that. Okay, and then if you look at what is crossed out here, in other words, take a look at this negative x tile and this, for example, positive x tile. Those cancel out. In other words, they're gone. We could leave them in there, but they're just going to end up canceling out anyway. So you're going to add positive x and then minus x. You may as well just get rid of them. So if you add all these up here, you get the answer 2x squared plus 13x minus 7. In the next video, I'll show you how to do it without doing all the pictures and stuff. Here we go.